Okay. Exponents are shorthand notation for repeating factors. So if you had 3 to the 4th power, that means the same thing as 3 times 3 times 3 times 3. 3 is called the base, and 4 is the exponent, or it also can be called power. Okay, we're going to evaluate some exponential expressions. So let's say we had 3 to the 4th power. Okay, that means you're multiplying 3 times 3 times 3 times 3. So if you just multiply from left to right, 3 times 3 is 9. 9 times 3 is 27, and 27 times 3 is 81. So 3 to the 4th power is equal to 81. And next, if you have negative 5 to the 2nd power, which is also read as negative 5 squared, that means that you're multiplying negative 5 times negative 5. And negative 5 times negative 5 is 25. Now make sure you notice the difference between the last one that we did and this one. Now on this one, this does not mean negative 6 times negative 6. This means negative 6 times 6. Since the negative 6 is not in parentheses, only the 6 is squared, not the negative 6. So when you multiply this, you get negative 36. Three times 4 squared. Make sure you follow your order of operations. A lot of people want to multiply 3 times 4 first, but we know that you always do your exponents before you multiply. So this would be 3 times 16, because 4 squared is 16, and 3 times 16 is 48. Okay. Now we're going to evaluate 3x squared when x equals 5. So that means we're going to put 5 in place of x. So that's 3 times 5 squared. And just like on the last problem, you want to do your exponent first. So you're going to square 5 first, and that gives you 25. And 3 times 25 is 75. So that would be 75. Okay. And I don't know why that 3x squared popped up there. All right, find negative 2x squared when x is equal to negative 1. So we're going to substitute negative 1 in place of x squared. So it's going to be negative 2 times negative 1 squared. Do your exponent first. Negative squared, or negative 1 squared is just 1. So this is negative 2 times 1. And then negative 2 times 1 would be negative 2. So that one equals negative 2. Okay, the product rule for exponents. Now when you're multiplying with like bases, you can simply add the exponents together. So a to the m times a to the n is equal to a to the m plus n. So if we have r to the 5th times r, we can just add the exponents together. Now make sure you realize that this r is to the 1st power. If you don't see an exponent there, it's to the 1st power. So this would just be equal to r to the 6th. Just add the exponents together. This one, since you're multiplying all of them together and they all have the same base, you would add all of the exponents together. So this would be s to the 2 plus 6 is 8, and 8 plus 3 is 11. So s to the 11th. Now on this one, you're simply going to multiply 6 times negative 2 like you always have. So that gives you negative 12. And then when you multiply the x's, that's multiplying with like bases, so you add the exponents. So it would be x to the 12th. So it's just negative 12 x to the 12th. And this one, you realize this is like having a 1 in front of this x to the 9th power, so this is like negative 1 times 4. So that gives you negative 4. And then when you multiply the x's together, you would add their exponents, x to the 9th. And the same thing with the y's. Add their exponents. So remember, this is y to the 1st right here. So it would be y to the 12th. Okay, the next rule is the power rule. If you have a power raised to another power, you multiply the exponents. So if you had 2 to the third, that's the same thing as 2 to the 9th power. And we could simplify that, but since we're just showing the rule right now, we're not going to simplify that one. We'll just leave it as 2 to the 9th power. So a power to a power, you multiply the exponents. Okay, x to the 4th squared, that would be x to the 8th. Just multiply the exponents. The power of a product rule says that if you have ab all to the nth power is equal to a to the n times b to the n. So in other words, you raise everything inside the parentheses to the nth power. So if we wanted to simplify 5x squared y to the third, you're going to raise the 5 to the third, you're going to raise the x squared to the third, and you're going to raise the y to the third. Now we are going to work 5 to the third out. Now that is not 15. You have to multiply 5 times itself three times because you have a base to a power here. 5 times 5 is 25 times 5 is 125. Now here, when they're both exponents like this, you do multiply. 2 times 3 is 6. So it's 125, x to the 6th, y to the 3rd. Alright, the next rule is the power of a quotient rule. And the power of a quotient rule says that if you have a over c in parentheses to the nth power, that's equal to a to the nth over c to the nth. So like on the other one, you're going to raise everything in parentheses to the nth power. Okay, now these are just some examples using the different power rules. If you have z to the 6th to the 3rd power, that's going to be z to the 18th. A power to a power, you multiply. Okay. Now in this one, we have to raise each part in parentheses to the 3rd power. So you're going to have to raise the -2 to the 3rd power, the p to the 4th to the 3rd power, the q squared to the 3rd power, and the r to the 3rd power. Now you have to work -2 to the 3rd out. That is a base to a power, so you have to multiply -2 times itself 3 times. -2 times -2 is 4, and 4 times -2 would be -8. -8, and then here multiply your exponents because you have a power to another power, so it's p to the 12th. And the same thing on the q's, q to the 6th. And then just bring your r to the 3rd over. So that one would be -8, p to the 12th, q to the 6, r to the 3rd. And on this one, we have to raise everything in the numerator and everything in the denominator to the 2nd power. So you're going to square 5 on the top. You're going to square x to the 6th on the top. You're going to square 9. And you're going to square y to the 3rd. Okay. Now 5 squared is 25. X to the 6th squared, multiply the exponents and you get x to the 12th. 9 squared on the bottom is 81. Multiply your exponents on your y's. So we have 25 x to the 12th over 81 y to the 6th. Okay, the next rule is the quotient rule for exponents. If you have like bases and you're dividing, you subtract the exponents. So a to the m over a to the n is equal to a to the m minus n. So when you're dividing, you subtract the exponents. So on this one, y to the 7th over y to the 3rd would be y to the 4th. Okay, on this one, now you don't have anything to combine with the 7, so I'm just going to bring it over. But you can combine your a's together by subtracting the exponents. A to the 4th divided by a to the 1st is a to the 3rd. And b to the 11th divided by b to the 2nd would be b to the 9th. So when you're dividing, just subtract the exponents. Okay, on this one, I can reduce the 9 over 3 first, which is 3. A to the 4th over a would be a to the 3rd. b to the 7th over b squared would be b to the 5th. Okay, the zero exponent rule. Anything to the 0 power is always 1, as long as a is not 0. So anything to the 0 power is always 1. So if you had 5 to the 0 power, that's equal to 1. If you have x, y, z to the 3rd and it's all to the 0 power, that's 1. Now be careful on this one, because only the x is to the 0 power, not the negative x. So this one, you have a negative out front, then x to the 0 power is 1. So that would give you -1.